Right. As I mentioned, I'm Andrea King. This is the PubHealthAI Collaborative Network, and today we're talking about local LLMs. Joe, do you want to introduce yourself quickly?
Sure. Hey, Joe Martin, working with LA County. So primarily, I'm just a data engineer, kind of handling. Um, we're kind of setting up pipelines for disease monitoring in LA County. So I do a lot of kind of got interested in local LLMs as a personal sort of side hobby because I kind of think they're fascinating. I've always been kind of privacy conscious, and um, I see that need across public health a lot. We deal with a lot of like sensitive data, and I feel like every day a new good use case kind of arrives. I was just sort of thinking about you could use it to anonymize your data as you could have it strip out PII, and then you could forward that to an actual larger cloud model. And anyway, there's a ton of applications there, and I hope we get the chance to tap into them. I'm really excited. There's actually an upcoming pilot project that we're working on, where we're basically doing. We are teaming up with the Children's Hospital. They are right. They've been completely understaffed for a while, and so their SAR kind of adjudication requests have just been piling up, and they've got a huge backlog of approvals that they need to work through, and a lot of these are pretty cut and dry stuff. Very very kind of like if if the person is diabetic and they've already gotten a diagnosis, we can go ahead and approve them. If they have scoliosis and the curvature is past a certain degree, we can go ahead and approve them. And so we are looking at we can talk a little bit more about the kind of the what we're doing, like a RAG database and that kind of thing. But we're looking at having local models analyze the request, provide a recommendation, and then you have someone in the office who can just kind of approve or customize basically the request for denial. And so yeah, so it's pretty cool stuff. Sorry, I got kind of went on a tangent there. But
All
yeah.
right. There's so much to explore, and getting into the actual concrete use cases is something we're going to do a bit more. So hopefully, just queued that up for you to think about potential use cases at your own jurisdiction. So let me get this going in here. Present the computer is really giving me a hard time today. It's not even showing my PowerPoint, which is fun. That's new. Just to reopen that. Apologies for the delay, but it just gives you an additional minute or two to think about your LLM use cases. All right. So, just to level set for folks who aren't as familiar with this topic, I'm going to go through some basics at the beginning on what we're talking about when we talk about local LLMs. So, this is AI models broadly. Most of us are familiar with the big frontier models from Anthropic and Google and OpenAI, but there are many, many models out there. hundreds of them. There are new ones coming every day from companies all around the world. And many of them are open source, and you can get those and you can install them on your own machines. And so we're going to talk through what kind of infrastructure you need to do that, how you assess what you're looking at when you're looking at models, and if there's a benefit for that to be considered in an enterprise perspective within your agency, or for curated projects, as Joe was just describing. So what are we talking about here? So LLM, that's large language models, but really these are language models of any kind. You can have small language models, like much, much smaller than these frontier models that are on the market now. So typically we run on cloud-based AI when we use ChatGPT interface, Copilot, Claude. Those they send and receive data through a cloud environment. So your prompt travels out of your machine. Everything's web-based, and it goes to their servers for processing, and then they come back with whatever output you've received. But the thing about those is that the data handling's controlled by the vendor typically, or whatever terms you agree to that you probably don't read all the way through, and just click agree. And then in an enterprise setting, that's whatever agreement your agency has made with the vendor if they're buying that tool, like for a Microsoft cloud platform or something like that. So we're going to talk about the flip side of that, how to sort of, rather than going bigger with the cloud, go smaller with local LLMs. You can run that on your laptop, you can run that on a server, and you have a lot of options for configuring your hardware. And these are, as mentioned, typically smaller, openly available models. And the big thing here that's interesting from a security standpoint is you can run without an internet connection once you have everything set up. So you can be completely air gapped, without an internet connection outbound. So any sensitive data stays within the environment you've created for that model to operate in. And I apologize, I can't see questions because I've got the slides up. So if you have a question, just go ahead, Jim. Feel free.
Angela, not to be nitpicky, but I did want to kind of add to that slide, and I'd be interested to hear what Joe's perspective is from LA County. But your definition and discussion of local models are exactly right. But from a hardware perspective, just to be clear, there aren't that many models, nor that many people running around with the right laptops that you can run something truly locally. I think where the real opportunities are available in models like Gemma and some of the other ones, you're still going to run them in the cloud or on some other server, but they are entirely local to you. So your data stays with you and your enclave, and it's not going into some open AI database in Santa Clara that you don't know what happens to it, which allows you to exert, sovereignty and data controls, etc. Just one.
Yeah, absolutely. That's a great point, Jim. Thank you for raising that. And we've got some slides on that a bit later, and what the scaling process looks like. As Jim mentions, laptops don't have the computing power necessary for some of these models that are more substantial. You can do very small, lightweight models locally, if you have a reasonably well outfitted laptop, but you would probably need some different hardware setups to really be able to run anything that's going to let you process data in a way that you're looking for with speed. So let's go.
I'll add one more thing to that. There is, there's sort of hardware kind of, there's typically two approaches to get good performance, right? You can go with graphics cards, which are fairly expensive, or Apple computers, actually the modern Silicon Macs actually use unified RAM, which gets shared between the CPU and the GPU. So which allows you, so if you still need a good chunk of it, right? Probably minimum of 32 gigabytes of RAM to start with, but that's not like unattainable. And then you can run fairly decent models on your laptop. Now that doesn't help you for something for like serving that wouldn't help you for like if you had multiple users, you'd have to do something else there. But anyway, I'll get to show that later on. Yeah. So back to you, Andrea.
Yeah, but you definitely pay for control with speed, depending on how you're set up, or like there are trade-offs to this, is where we're certainly highlighting here. But so why does this matter in public health? These conversations have come up a few times recently. I've talked with some folks at ASTO about this. It's a viable option for agencies to build knowledge around. We've certainly talked about it here before as well. The privacy considerations around the types of confidential data that we work with in public health is one reason that this is a popular line of inquiry, that you can keep everything in your managed infrastructure with your local hardware if that's where your jurisdiction set up. You can all argue that you have the same options in a cloud environment typically, but it does make governance a little simpler because you don't have to go through that additional layer of the vendors' terms and conditions and the agreements you're able to arrange through your contracting processes. But it can work in restricted settings if you have low connectivity areas. I see somebody. I've got the chat up now. Local computing is, yeah. This is edge computing at its core. That's kind of an overlapping definition. I think that is, especially in this section of resource restricted settings where you don't have connectivity and Wi-Fi and bandwidth to run these things. That's typically how I think of edge computing. And the fact that there's not a per use subscription arrangement with these models is also pretty appealing. But what you're not paying for up front with a curated model platform, those costs shift to your hardware and the staff time and expertise to manage the deployments that you've got going on in house. And one point I want to make around this is that the cost of the model that we use now, models, if you go take $20 a month for Claude or something, those are heavily subsidized right now. Like whatever you're paying is not what it costs Anthropic to provide you with those services. So that's not a sustainable arrangement long term. Like these costs are going to change. I expect on what timeline, I don't know, but the subsidization is probably going to shift some of that cost at least back to the subscribers at a certain point. So just the current pricing models probably will be variable, and having a local option helps you control that side of the cost picture. All right, and Joe, let me turn it over to you now, and you can show us what these things do. Tell us about it.
Sure. Oh, you know what? I'm so sorry. I need to fix permissions. I'll be right back.
Yep, no worries.
I totally should have done it for the meeting. Okay, one second.
I see Ian's question about projection about what costs may be in the future. Hard to say. It's dependent on so many factors that influence the cost of actually creating these things, that billions of dollars it takes to generate new models to start with, and then cost of computing, then all the resources that go into it, and as well, kind of like all the hardware that they have to sustain to make these things work. So unless those costs come down, it could be substantial. All right, Joe.
Oh, I think you might. Okay, let me try again. There we go. Thank you. That's just how privacy conscious I am. I kind of disable the screen access after every meeting. So hey, so yeah, I kind of wanted to take a moment to demystify when you're setting up a local LLM, you kind of immediately get overwhelmed with these options. And so, the I think we already kind of covered what a local LLM is, but one of the first things that you'll have to do is pick a model that you want to run. Um, and so you can kind of there's you're right, it's just you just kind of let the information wash over you because there's a lot there. So let me break this down for a minute. I think the first thing that you notice is the model family, kind of who is the company making this large language model. And there's just a number of top contenders. The real standouts are Quen. Gemma from Google is just really impressive in my opinion. DeepSeek has made the news. Mistral, you've probably heard about, and of course Llama from Meta. So those are the people kind of making these models. They're the ones kind of spending the compute to train these, and then open sourcing the weights so that we can utilize them. So that kind of tells us who made the model. Now, how do we decide kind of from there what model to pick? So you basically you need to pick a model that's going to be fit in your hardware. And we touched on this just for a moment earlier, basically, and um, you want to right size it because, as someone in the comments mentioned, and he made a good point, right? These smaller models, they are noticeably less intelligent than the large cloud provided models that we're used to using, and there's a direct correlation to size. That correlation has gotten fuzzy. I mean, if you compare but okay, sorry. So for instance, like if we look at the chart here, like a 1B parameter model has a billion parameters. That technically means you can think of that as like a billion neurons in its neural kind of map, in its neural network. That Running that at full precision would take about 2 GB of RAM, video RAM, or Apple Silicon, just kind of regular RAM. So that's kind of the back of the napkin math. Now, obviously, as you go up and as your neural network gets larger, it takes more and more RAM to fit that on your hardware. So, right, that's kind of how that works. One trick that people are doing in order to get larger models to fit onto smaller hardware is a technique called quantization, and you'll hear that a lot. So I just want to cover it a lot. Quantization, it's you can think about it as kind of rounding off the numbers. If And this might be getting too much into detail, but basically you can think of the weights in this neural network as these big long numbers, basically, and as a sort of thought, or really, as a wave of prediction moves through that, we multiply by these numbers and we get a result at the end. That's our kind of the model's output. Um, so each weight is kind of this big long number, and when you quantize, you just sort of round off the end of that number a little bit, so it becomes a little bit smaller, a little bit easier to multiply, meaning you can fit more of these parameters into RAM, so you can get bigger models into smaller spaces. So that's good. But you do that too much, you round off too much, and you wind up with a model that just sort of is kind of lobotomized. It just really doesn't know what's going on, and it really loses the plot. So here's a good cheat sheet for kind of where you want to go with your quantization, and you typically want to stop around Q4. Anything below that starts to get poor output quality. And then that's kind of the hard math part about picking a model. Then you get into, I think, maybe the softer skill part, like after parameters. And quantizations, you know, a, a big model can still make dumb decisions if it was trained on the wrong data. And so now you need a kind of a third technique for picking out something good, and that's actually evaluating. That's where kind of evaluating a model comes into play. How do we tell if one model is better than another? And previously we would go to like the Hugging Face kind of leaderboards where they'd have these basically they would run these tests against these models and see how well they performed, and give them rankings and stuff. But as these tests get publicized, they actually become part of the training data for newer models. So old tests quickly become obsolete, and it's just this cat and mouse game to try and figure out like what models are good. So the kind of the I think the the modern approach is to kind of look at the LM arena and let's see if we can, let's see if we can. I can't filter this by local, but it's still interesting to kind of scroll through here and see, Claude Fable 5. That's been in the news lately because it was basically redacted from the public, and now it's been released again, which is, great marketing for Anthropic, by the way, in my opinion. I don't know. This all seems like a marketing stunt to me. Just like, it's so good that we can't even release it. Um, but and you'll notice all the top of the chart are basically just all of these cloud provided models. It takes us a while before we get to some like Kimi, I believe this is open source with a modified MIT license, but it takes a while before we get down here to Gemma, which is an open weight model that we can download. And actually, that's a 31B model. That is like, approachable in terms of RAM. But the evaluations that these people use, they're good. They'll ask like hard math, hard science questions. And this is a good measure of generally how these models are going to do. But it's always better. We have specific workloads, specific use cases that we want these models to perform well at. So it's really a good idea to have your own set of evaluations that you would run internally against a model so that you could, and once you have like, here's the question I want to ask a model, and here's the result that I want it to go for, you can repeat that same process across a number of different models and then find one that works well for you. So a while back, actually, this is kind of an interesting experiment. A while back, Andrea, you took an MMWR report from the CDC and you fed it to the cloud models and you said, "Hey, generate me an HTML map showing kind of where all the measles outbreaks are happening." And I was like, "Oh, that's a great idea. Let's try that with these local models. Let's see what happens." So I fed that into Quen 1.7b, and here's the map I got. So just nothing there. Now I'm sorry, this was like over a year ago at this point. So this is old. So this is Quen 1.7b. Not great. Okay, so then I upped it to Quen 32b, and actually, it's not like terrible. It was able to kind of extract some points. It totally missed Texas. I think it got, but we do see some dots. It's not very informative. It's not very fun to look at, but it's still something better. And then I
And it
went
also
to
means that it's calling tools behind the scenes. Like it's got some extra functionality in there if it's able to generate and leaflet.
yeah, yeah. Um, so I did the same test with Quen 235b. This would be a model. This is 235 billion parameter model. This is way too big to fit on my machine. But now we're getting something kind of comparable. I actually had to, so I couldn't run this on my machine. I was using Hugging Face Spaces, which is you can go online and they'll let you use their hardware to run these models, which is pretty nice of them. And then as a comparison, I did ChatGPT. So, and this is definitely, I think the best so far, just in terms of kind of, visually. Um, so then I wanted to do the same test again today and actually run it against a local model. And I used Gemma for this. And I didn't have the MMWR report. It's a totally fair test. However, I did give it, let's see. Oh, I revealed the map too soon. Uh, I did give it access to the internet, and I said, "Can you search for the latest measles outbreaks and generate an HTML map?" I did tell it I wanted it to use Leaflet.js, so maybe that was a little bit of a helping hand. And kind of, circles should be larger for larger outbreaks. And it was able to actually give me a pretty comprehensible map. And so anyway, this is a huge improvement from where we were just a year ago. So these local models have come a long way. Um, and that's a good segue into kind of what I'm using here right now. So I actually was able to run this. This is Llama CPP, which is kind of in the past I was using LM Studio to preview the models. But I thought for the purpose of this demo, I really wanted to play around with Llama CPP. And now I've got this is my Mac with like an absurd amount of memory, so I can run this fairly well. But we could say like uh right, can we say like if I do this, let's just do this prompt again. And we're getting about 20 tokens a second here. It's not as fast as a cloud provider where you'd get like hundreds of tokens per second, and this would just kind of unfold in real time and do it for us. But this is still we're at a pretty decent generation speed here. Um, and this was, you have to be a little bit familiar with the terminal, although really I just talk to Claude now, and I just say, how do I set this up on my MacBook Pro? We can install Llama CPP here, and then we can automatically run and download it using this command. And then after that, navigate to this kind of in your browser. So it's been pretty seamless to get set up now. And I really like Llama CPP because LM Studio, and I think we did discuss this last time, it is a closed source application. Now, I'm sure they're trustworthy, but being closed source, it's a business decision. I get it, but I just Llama CPP is completely open source, so it just makes me trust them a little bit more. Plus, I'm fairly certain that LM Studio just is a wrapper for Llama CPP. So yeah, that's why I would reach for it. Um, so yeah,
Yeah, this has come a long way.
yeah. I was really blown away by the map it was able to put together.
Yeah, and the
Um,
fact that it gives you the data that it's pulling, and you can have that reference back to the origin of what it's gone and grabbed from that very basic prompt.
yeah,
Danielle's got a
right.
question. Go ahead.
I have a newbie question for Joe. I just wanted to come back to something you said related to open source versus closed and the reliability or trustworthiness. How are you making that decision? Can you say a little bit more about that?
Oh gosh, that's a really good question. I mean, and just just the difference between closed source and open source is closed source means that the code, the source code that the program uses is just completely private. I can't inspect it. I can't look at it. Open source means that it's like posted on GitHub. It's publicly available. I could peruse the source code if I wanted. Now, did I do that? No, I did not. I have not looked at like I've like skimmed the README of the source code for Llama CPP. However, I kind of have trust in the community at large because it's open source. There's going to be so many more eyes on it that if they're doing something malicious, then some watchdog will raise an alert, and it'll be easier for that watchdog to do so because it's open source. So that gives me a little bit more faith, and that's my main argument. Ronald, yeah, go ahead.
Yeah, I sorry. My last foray into running local models was like when Llama 2 had come out. I was like, oh yeah, this might work exactly for this problem, right? And I just remember getting stuck in this web of TensorFlow and Hugging Face and eventually muddling through, but it was a mess. And that
Mm.
was easier than before, right? Than it used to be. And I'm wondering, could you talk a little bit about the breadth, especially for having shown some of these models? And I'm imagining a lot of the different kind of hardware that different staff will have. Um, what does that look like? And maybe it's just going to Claude Code and saying like, "Hey, make me a walkthrough" is the best way now. But what kind of are the like technical skills necessary to set up an environment now?
Oh, it's gotten right. Claude Code would I think you'll have a specific environment, and Claude Code will probably Claude or ChatGPT would be able to speak to that specifically. If you like LM Studio would if I'm to give just a broad general suggestion, I would say LM Studio is like the quickest way to just install something, get up and running. It'll have these you know, it'll have these like when you go look for a model, it'll say, "Oh, hey, this one's look good." You'll be able to run it on your machine. It's a staff pick, you know, it'll kind of guide you toward models that are good. Now, depending on your hardware, you will probably not, unfortunately, you'll probably not get these speeds unless you're running like an Apple Silicon Mac, or you've got like the Strix Halo machine, which also does like unified memory, but no one has probably even heard of that. That or unless you have like a really nice gaming PC, it's going to be pretty difficult to hit good speeds. You'll hit you can hit okay speeds with RAM, like 5 to 10 tokens per second on a small model, I think. But yeah, you'll be limited on your tokens per second for sure. I hope that answers your question. Um,
I was, I for my hobby work, I'm definitely in that nice PC realm, but it's more the I'm wondering about the install thing. But yeah, so you're really just recommending, no, use this environment here, right?
LM Studio, I think, will get you going really quickly, and it has a nice UI. Llama CPP is just as quick, in my opinion. You just have to be like some people are. The terminal is really scary for a lot of people. If that's not for you, I'd say go Llama CPP. I think it's going to be
Mm.
faster and better because you'll get. Llama CPP has always been like slightly more optimized than everything else. Llama CPP is what everything uses. Every UI for local models just wraps Llama CPP, and wraps like an older version of it. So Llama CPP is always like a month of optimizations ahead of everything else. So just go for that if you're comfortable with the command line.
I see
Thank
a
you.
comment
And
from
of course, oh, sorry.
I see a
Oh,
comment from Tyler in the chat as well that that you could also leverage integrations in R and Python to call local LLMs from those packages if you're trying to if that's more your comfort zone and you're just trying to explore what the local models could do. Go ahead, Ronald. Sorry.
Um, and I did want to hear from Francisco. You've had your hand up for a minute.
Yeah, I think, and this is also like sort of like newbie question. And I'm wondering about the grounding of these models. One of the things I have considered these small LLMs. So can you ground them on like a curated local, knowledge base that you have, or yeah, how does that work?
Yeah. Yeah, there's absolutely there's a couple ways to do it, and the so there's two big approaches that stick out. The first one is RAG, using a RAG database, and the second is fine tuning. Um, a RAG database, my I think is a good fit. Okay, so I talked earlier about this about these SAR adjudication requests, um, and what we're looking at, actually, I might be able to show you kind of a little bit of what we're doing. Basically, like we're and this is all just test data, but so in this case we're using a RAG database as the back end. They have this giant manual that outlines how they should react in most cases, like, right, the scoliosis curvature, and various other conditions. So what you can do is chop up that manual into all of its sections, basically. And then this part's a little weird, but you actually, when you insert those chunks into a RAG database, it does semantic analysis on that chunk. So it actually reads the words. It'll read, like, it'll then, and this is actually a RAG and a RAG chunk right here. This is an entry we pulled out of the RAG database. When it gets inserted into the database, the RAG database is special because it reads the words in this chunk, and it basically, like, kind of adds semantics to it. It gives it semantic meaning, so that later when I come through and I say, okay, I've got a patient, Marcus, he's a 12-year-old with hemophilia, currently managed at such and such, requesting renewal of his replacement therapy. Then we say, oh, okay, let's go search the RAG database for, like, things related to hemophilia, and then we'll pull back these two chunks will come back from the RAG database, and then those go into the context. They go into the prompt for our LLM, and we say, okay, we've got this patient. Here are the two entries from the database that we're pulling back. Can we make a determination on this case, basically? So that's actually a really nice way to ground your LLM in kind of real world stuff, because one, right, you're able to store, you've got the real source of truth here from our document in the RAG database. And two, okay, this is going to make sense in a moment when I talk about fine tuning, but you don't need to update your model. Let's say the guidebook in the future changes. You can go to your RAG database and you can update the entries in your RAG database, and your model gets to stay the same. Fine tuning is this different approach where you actually, I think I've got a slide on it. So let's say you wanted to enhance your model. Let's say you asked your model, you know, like, let's say, for example, you had a model that didn't know how photosynthesis worked. And you wanted to teach it. Well, you can come up with a bunch of fine tuning example data, which is basically just, here's the instruction, and here's the inputs that I might give you, and when I give you this such input, this is the output that I want you to give me back. And you have a bunch of those questions, basically, and then you can use there's training processes that you can do to take these question and answer responses, feed it into the model, and then the training process will literally go into that neural network and update those weights, so that as our kind of as we kind of work our way through the neural network, it reacts. We kind of bounce along different neural threads, basically, and we come up with a slightly different answer. We come up more so with the answers that we want. That's in the fine tuning example data. So now, compare those two approaches with the RAG database, right? The model gets to stay the same, but the context, the prompt that feeds into it, you can update that in the future, which is really nice. With fine tuning, you get to update the model itself. You bake in this extra knowledge to the model, which is nice in some cases too. Like, for example, I think earlier I was talking about like that redacting PII from a document, basically using a model to like look at a piece of information and redact all PII from it. That would be a good example for fine tuning, right? You wouldn't want a RAG database full of like what is PII and what is not. You would but fine tuning would be a better fit there. Yeah, so that was a lot. Those are kind of the two main approaches you'd see in grounding your model.
I wanted to flag out
yeah.
a question here too that came through a few minutes ago because it related to agency level adoption from Abhinav Nala in Michigan. So how will the local models work if there's a hybrid need to run an AI query locally and then also against data that's stored in a data lake or like an enterprise cloud? Could we talk through some about how you could have a local LLM running for some things, and then if you need to query out, how that would work? If it's all
Yeah.
within an agency's environment, I think that makes it a lot easier. You can have a hybrid structure where your local LLMs are still deployed in an agency's private cloud if you have that sort of arrangement. Or Jim, I see your hands up. Go ahead.
I was just going to add, if you've got a data lake configuration, then you're obviously well invested in something like Azure or AWS. And I'll just speak to AWS. If I have an AWS data lake, I can leverage AWS Bedrock as a existing AI platform within the system that will route me to one or more models that I choose to use. I could choose to use one of the big frontier models, or I could have a host of local models running in my AWS environment, and Bedrock and Bedrock tools can help orchestrate that sort of thing.
Yeah. And backing up just a step, what you're kind of talking about is the concept of orchestration. You really like, when we're talking to a model, it's no more special than doing like a web search or hitting an API to get the weather. But instead of getting the weather, we're asking, like, what's a good brainstorming idea for my local LLM presentation, and then we get back a response. So you could orchestrate a pipeline where you say, how can you look at all recent health data for this clinic, and then come back to me and tell me, are there any anomalies in our patient care? Is there anything weird going on or something like that? And the model itself could detect. You could supply a tool to the model so that it's able to query the data lake, or and then get back the results, have it process the results the same way. You can build out these pipelines where you can construct the prompt. You can let the model kind of make its own decisions about what it wants to query. And yeah. Sorry, I was hoping to kind of put a finer point on that, but that's the basic idea. Is that just as we're making API requests and doing processing in a classical programming kind of way, we can asking AI to make some judgment call about about the data we're analyzing is another technique in our bags. I did want to, let's see if I can open this. This was something I keep talking about this method of, let's see if this still works, of how neural networks kind of work. And the really neural networks work by they really just they always just predict the next word. And let's see if we can we press play? Anyway, so on the left, we have kind of our starting sentence. Data visualization empowers users to, and then it runs through the neural network, goes through all those weights, and what we end up with on the other side is the same sentence. Data visualization empowers users to, but then we get a probability distribution on what the next word should be. And here we have, visualize as the top hit, but it could also be create or see, make, easily, and then the scores kind of drop off after that. And then actually, this is interesting because in this case, it actually chose C as the next word for this call. Now that's due to a number of things like temperature and what it's going to do. But yeah, we can see this. And if we run it again, we start with the sentence: data visualization empowers users to see the right, and we can kind of keep doing this to just watch the watch this LLM kind of predict the next word. Behind the scenes, every LLM is doing exactly this, just really, really, really fast. And it also kind of explains, you might notice this when you're playing with local models, the larger your context grows, the slower things start to get because it has to do more and more math to predict the next word.
When I've seen this example run, it always like it toggles between those first two or three. It's funny, like the explainer isn't even stable in its own sense.
Yeah.
Like it's LLMs for you though. They're a little squirrely, even
Yeah.
still. So,
It's kind of interesting. We can see, right, as we adjust the temperature, the percentages for the next word kind of vary. Presumably, if you had temperature 0, you should get the same results every time.
sure. Okay, let's go through the lots of comments in the chat. Does anybody have questions or anything to add to where we've taken this so far?
Andy?
Andy, hey.
Yeah, I want to see if you can say anything about the way in which token usage can sort of run away when you're in the middle of a workflow and you're having to submit that, there LLMs are stateless, right? Meaning that they don't remember the last conversation that you had. The only reason why it seems that way is you're submitting the same information again with your, second and third prompts. You're submitting the previous ones again, and so your token usage kind of goes up. Can you say something about that how you control that or monitor that?
Sure. Um, you
And
know,
maybe explain also, in case folks here don't understand what I'm talking about stateless.
yeah, it's right. It's so when you Yeah, LLMs. I mean, stateless kind of means that like each time you start a new chat, you're essentially starting fresh. There's some caveats there, but that's the idea basically. Like when you start a new chat, it's not gonna you're talking to a brand new thing basically. I almost said human being, but that has no memory of what occurred before, and you'd have to explain everything from scratch. Now, there are good ways to mitigate that. One of my favorite approaches is, let's see if I can pull this up. So what I like to do is, let me see if we can look back at like. What I like to do is with Claude, I'll say something like, I want to build out, like in this case, I'm trying to build out like a project manager agent. Um, and to build out let's say, um, a scheduling agent. Um, and what I'll do is I'll say, can you grill me on how this should work? Then create, this is the most important part, then create a plan.md, a markdown file. I'm going to call it scheduling plan because I have a lot of these that conflict. Have it create a plan, um, uh, uh, outlining the implementation we are going to do. And so two things are happening. One, it's going to there. One, it's going to. I've got a skill called Grill Me, and that's this is kind of the less important one, but and skills. This is let's see. So this is runs basically skills. There's not a ton to them. They just kind of have a fancy name. A skill is basically like a saved prompt that you want to tag with a name. And so when I say grill me, it knows to do this, basically grill the user relentlessly about a plan or design. And so let me put this in auto mode. And so it'll ask me a bunch of questions about like, do you want it to work this way? Do you want it to work that way? Here's some consideration you didn't think of. How do you want to handle this edge case or this scenario? Um, and that's great, right? That helps you flesh out this idea that's in your head and get it in place. Now, but as it's gone through all of that, all of those questions, basically, it has um, it has really filled up the context, right? And so here we go. Let's say this is a standalone, like I don't want to. I'll probably stop there, but the idea is after it's grilled me to its satisfaction, and we have specced out this entire project, then it's going to create an implementation plan that captures everything we talked about. And so that'll highlight like the tech stack I want to use, storage approach, directory structure, all this sort of stuff, all of the decisions that we made together. It'll condense it, it'll put it in a straightforward way. And then what I do is after I have my implementation plan, I clear the context again. I start from scratch again, and I say, okay, Claude, look at the implementation plan and implement what we have there. And it starts from here. It starts from this like condensed context, and it will build out like everything we discussed, because it was able to capture our decisions here a lot more cleanly than the kind of blown up context that where I was just sort of like talking too much, basically.
And to add to that, what I do when I have like a really heavy session, like an implementation plan that's going to be blowing the context window multiple times, I sort of stack it into smaller chunks, and then I have Claude write its own handoff documentation, just like with even within that plan. So it'll say like, you know, I'll have it do a certain chunk, commit all that to GitHub so I don't lose anything, and then clear this, like have it write a handoff, like detailed handoff for itself that's going to live in a persistent location. And then I clear the session, and then I have it pull that handoff up, and I'll say read handoff, you know, section
Yeah.
whatever. And then tell me what's next, because I know what should be next, but I want to know if it knows what should be next
Right.
based on what it told me it was going to do in the handoff. So
Yeah.
you have to really think about how to triage that memory in a way where it's not going to get lost in its thoughts because you've covered so many things in one session. So the more discreet you can be about how it's using its memory, and then clearing that off, and then just maintaining your documentation separately so you can always pick back up in case there's a hiccup is that's my recommendation. It works well for bigger projects.
I like that.
Markdown files are your friend no matter what model you're working with, because it lets you transfer context across windows. So if you have something like Copilot that's got a pretty small like context window, you can use Markdown files to just keep things running across sessions if you're not in an environment where it's retaining things for you.
I like that a lot. Uh, yeah, but no, but that's a great question, because that's absolutely a problem we run into. One thing, and then I think I feel like there's some uh yeah. I think reading the best practices for Claude is a pretty good answer to this too. It definitely talks about how its context window fills up and performance degrades as it fills up. Um, and you can set goals, which are cool. And this is kind of like what I just said: plan and then code. Um, uh, there was one more in here that I'm forgetting about. Oh yeah, letting Claude interview you. That's kind of like that grill me skill. Um, uh, yeah, I'm sorry. I'm forgetting, but there was kind of one more point I had, but yeah.
No worries. Well, we've gone a little over here, but that's what happens when you're when you're deep in something and you're learning. And I'm cool to keep the line open. We've got plenty of folks on, so let's keep chatting for a few more minutes. Tyler, go ahead.
Yeah, I just want to give a little more context. I see some conversations going on in the chat. And, one of the things, and sorry, I didn't have, robust example. I'm still learning in this space, but one thing that I would be really curious with local LLMs is, and I mentioned this in the chat, is I see in public health data systems where we have free text narratives and we're trying to, for example, out of a giant pool of healthcare encounters, what are healthcare encounters for the condition we care about, or other some sort of similar tasks where we're taking some text and then we're trying to classify a record based off of that text. And one thing that I would be really curious about is kind of a lot of standard practice I'm seeing is advanced Boolean logic. So match this term and not that term and all the combinations. And so it'd be really interesting to see how these different technologies sort of line up, like our standard practice of Boolean matching, regex, kind of getting back to Ian Painter's past presentation of, more traditional ML supervised. And then maybe on top of that, Joe, your presentation of like a local LLM. So you can kind of see as you kind of go up this gradient of maybe complexity or
Yeah.
technical hardware needed, what does that mean for performance? And obviously that varies across tests, but the one thing I'll just quickly say in my limited testing of this space that I've been excited about with scikit-learn and Python that I put is that it provides a similar coding framework, so you can test, a logistic regression model or a machine learning, a traditional machine learning model, but then you can also overlay these LLMs, so you don't have to write a ton of new code, but you can kind of
Yeah.
swap out the widgets that you want to try that classification piece on. Yeah.
Yeah. No, I think we're it's incredible how quickly you can build now, and how I've gone from code writer to just code reviewer at this point, which is should I be more scared? Maybe, but I don't know. I'm having fun. Um, and yeah, so right, and I kind of I think about the like you said, the kind as these the Boolean logic determinations we're using now, I think um, we'll see these cases get split by complexity. I think that there will be clear-cut cases where, which is just like search for this word or search for this diagnostic code, and we can make a decision based on that. But then there will be more complex cases where, maybe we need to analyze an X-ray, or there's been inconclusive results or something like that, and where traditional kind of like workflow logic, just it'll fall short. Um, that's where LLMs could kind of come in and help um, help guide people to the right decision, basically. Um, Yeah. And if it sounds like you're already kind of using AI to build too. I'd highly recommend Claude Code for these things, just for the capability it has to write, even if we wanted to say, like, okay, I want to build a model that can look at an X-ray, where do we get started? And it'll just probably be able to guide you through most of that process.
And it does
Yeah.
a lot of good work on the data engineering side of things. Like if you need to troubleshoot permissions with a service account or something annoying that you don't
Mhm.
really want to spend personal time on, but that can be a
Yeah.
real blocker if you're in, a typical, kind of workflow for those sorts of things. You can solve those problems in minutes instead of like hours of just fooling around.
It's been a
Which
it's
it
been a
saves
long time
me
since.
a
Yeah.
ton of time if you're trying to connect across. I've got Claude on my machine, the Visual Studio GitHub for just review, and then everything else pushes to Google Cloud and pulls in a bunch of tooling over there, and it's seamless. It's really neat. So, um, highly recommend Claude Code, same as Joe. And the quality of the output is good.
Yeah. This reminded me. This is a failure. This is kind of a an issue I see people with, when they're using LLMs. That, like if it gets something wrong, they'll correct it, and they'll keep trying to correct it with each little thing they get that it does wrong, and you wind up really blowing up your context with continued kind of repeated failures. Um, there's kind of, you could either clear the context completely, and start from scratch, or another technique I like to do is sometimes you can go back and say, like, edit your response and say, um, avoid doing it such and such way, basically, and that'll fix it too and preserve your context. Sorry, just remembered that. I wanted to get it out there. That was something that I like to do. Oh man, yeah. Oh. Yeah, I was just thinking about that. We used to like I would spend sometimes like weeks just like looking through Stack Overflow for some obscure solution that was just never found. Really, it made me want to change careers sometimes if the problem was just like so opaque. That hasn't happened since I started heavily using AI. At least not seriously. There's still some weird stuff that comes up. Sometimes I've noticed with like home network troubleshooting, it can get a little it can kind of not get it. But for the most part, yeah, I don't feel like I've been blocked in quite a while, which is wild.
Well, it's because it reads the documentation better than we do.
Yeah.
Is
Yeah.
really the answer. Like, I mean, yeah, I feel you though. I kind of gave up on coding because I was just like,
Yeah.
this is exhausting.
It's frustrating. There's very frustrating moments when you just try over and over and it doesn't work. Yeah.
But that's
I
also
don't
how you
I,
learn, and there's some
yeah,
value to that you build the skills that you can use to credibly assess what you're being shown with the model.
right.
And like you got to kind of go through the pain to know what you're looking at to an extent but
Hmm.
so you don't want to have like total skill degradation, but it certainly it makes it a lot easier for sure.
Yeah. Yeah, I know. I wonder about that too. It's just the struggle, how much of the struggle is necessary to, you know, um to be good. Anyway.
We'll find out something for future graduates to worry about. Anyway, thanks to everyone for joining, and for those of you who stuck around. This is such an interesting topic, and I think we'll come back to it because there's so much here. And Joe, thanks for being the pilot for this session. I
Sure.
always learn so much when I talk to you about these things. And Tyler, everybody, we'll catch you next time, and we'll be talking MCP with the Yale crew from PubHive.
Oh,
So
great.
until next session, take care, everybody. Bye.
Thanks.